Hello, welcome to the Bakwas channel for self-paced tutorials on Internet of Things. This video introduces the NVIDIA Jetson Orin Nano Super Developer Kit SDK to evaluate basic artificial intelligence applications for vision or generative AI projects. The NVIDIA Jetson Orin Nano Super Developer Kit is a powerful single-board computer. While we await the Jetson Thor based on Blackwell architecture as announced at the Consumer Electronics Show 2025 in Las Vegas last month, we can enjoy the revised version of the Jetson Orin Nano with the sweetened reduction in price. This product now has the suffix Super Developer Kit or SDK. The sales pitch is towards generative AI for this board, but in reality, it is suitable for many other applications, including robotics, since it will run Jetpack 6.2. There are two hardware parts to the kit. There is the Jetson Orin Nano module and a reference carrier board. The module has the ARM CPU and the Ampere architecture GPU. The carrier board has interfaces for a wide array of connectors, including two camera connectors, dual M.2 connectors for solid-state drives, and a 40-pin expansion header a la Raspberry Pi. There are notable third-party vendors who manufacture their own version of the carrier board. One such company is Seeed Studio. Their version of the carrier board has a more efficient way to attach a battery for the onboard real-time clock. There is a minor issue with Docker under Jetpack 6.2, but since the best brains at NVIDIA are working on a solution, we will soon put the issue behind us. There are three series of products in the Jetson Orin family. The AGX Orin is at the top apex. The Orin NX is in the middle. The Orin Nano is at the low end, but nevertheless better than using other general-purpose single-board computers for AI evaluations. Our focus is on the Jetson Orin Nano. The 8 GB version of the Jetson Orin Nano is now marketed as the Super Developer Kit with an AI performance at 67 trillion operations per second. The 8 GB memory on the Orin Nano is a limitation when using upper-end large language models. NVIDIA should have offered double that amount because generative AI exercises do need more memory for the popular models. There is support for NVIDIA software, including Isaac, ROS for robotics. The Jetson AI Lab for text generation, text plus vision models, image generation, and distillation techniques makes the Orin Nano a solid partner for starting development and learning with generative AI solutions. Let us take a quick look at the connections on the board. The box contains the Jetson Orin Nano module with the NVIDIA reference carrier board mounted at the factory. There are other companies offering their own variations of the carrier board. The one by Seeed Studio seemed attractive because it has support for easy installation of the real-time clock battery. The Wi-Fi and Bluetooth modules are pre-installed too. There is a 19-volt, 25-watt power supply converter with a barrel connector to the board. To run the Orin Nano, you will need either a micro SD card or an SSD drive. Naturally, the latter is preferable. There are 4 USB 3.1 Type A slots. The keyboard and mouse connections will use one or two of these. The carrier board has MIPI CSI-2 interface for 2 cameras, but it supports USB webcams also. The display monitor screen will interface to the board through the DisplayPort connection. There is a 1 gigabit Ethernet interface. And for connections to a desktop or a notebook, there is a USB-C port that is limited to data transfer only. The connections to the 40-pin expansion header is along the familiar lines of the Raspberry Pi computers. This will be explored in a separate tutorial. Of course, external resources, for example, a desktop or a notebook, is required to flash the micro SD card or the SSD drive based on chosen options. The factory-delivered Orin Nano has old firmware that must be upgraded before Jetpack 6.2 can be deployed. Jetpack 6.2 provides better access to packages for AI development activities. This update process requires 3 reboots for the changes in firmware to become effective. Flash a micro SD card with Jetpack 5.1.3 from your desktop. You may have to download this firmware from the NVIDIA site to a computer that can flash the image to a storage medium. The link is noted in the description section of this video. We will reference the boot device as a micro SD card, although an SSD drive could have been used as well. Boot the Orin Nano with the newly flashed micro SD card. Reboot for the first time with Jetpack 5.1.3 to schedule firmware update. Reboot for the second time with update firmware. Run Quad Serial Peripheral Interface QSPI update. Reboot for the third time, observe QSPI and shut down. Cold boot with Jetpack 6.2 and validate that the firmware is 36.4 or later. Unlock Super Performance by setting mode to Max and Super. Start your activities using the latest and greatest Super Developer Kit for the Jetson Nano Orin. You will want to use an SSD instead of the micro SD card, especially if you introduce multiple Docker environments that require above average storage space. I'll give you the long-winded approach to downloading Jetpack 5.1.3 in case you get lost at the NVIDIA website. So we go to NVIDIA developer site and look at some of the options. And the best thing to do is go ahead and select the platform that we're interested in, which is the Jetson platform for our Orin Nano. And in here, we have Jetson developer kits that we should select. So I think if you're not familiar with this page, go ahead and read some of the information and the warnings and the preparations that you need to do. Once that's done, you can go to the download center and take a look at some of the options available to you. Our focus is primarily to get the Orin Nano up and running for the latest Jetpack. Unfortunately, the firmware does not allow us to do that directly through the best tool that is available, which is the NVIDIA SDK manager. So we do need to go ahead and download an upgrade to the firmware Jetpack 5.3.1. And this is explained on this page here with clearly what are the requirements. Once you have a basic understanding, you can then navigate to the site where the Jetpack is explained. So here's our Orin Nano, and we're going to go ahead and then navigate to fulfill this message here, which says update the firmware. You do need this if you are using an unboxed, factory-supplied Jetson Orin Nano. So we go down here and it's going to ask us to go ahead and flash it. And here's the explanation. It does not work directly with the SDK manager until you have upgraded the Jetpack. And so the first step is to upgrade the firmware using Jetpack 5.1.3. Ideally, this should be done on a micro SD or an SSD. For this demonstration, I will demonstrate the micro SD card, but in production use, I wouldn't like to call it production, but in full-fledged development mode, please try to get an SSD if you can. So I'm going to go ahead and select on this option, and it's going to tell me the options to go ahead, and so I'll click on follow the instructions. And again, this is the initial setup, very, very important. Otherwise, you'll get lost. And here's the explanation of why you would want an SSD versus a micro SD. Although, again, I'm going to demonstrate only the micro SD for the first part and eventually. So the image, whether it's micro SD or SSD, is still the same link. And on this page here, you can click on this and you can see at the top of the screen, it starts downloading immediately. It's almost an 8 gig image, so it'll take a few minutes to download, and I'll stop the video for now. The downloaded image file is in zip archive format. However, any imaging software that you have, Balena or the Raspberry Pi, should be able to use it as is. It's 8.8 gigabytes large, and I will be using the Raspberry Pi imager. But of course, you can use any other imager that you prefer to flash this image onto a micro SD card. Before we connect the micro SD card into its slot using a tweezer, let's go ahead and flash it. We'll use the Raspberry Pi imager for this purpose. The three key parameters are, since this is not a Raspberry Pi device, we specify no filtering. For the operating system, we specify the package that we just downloaded, and the storage will be the micro SD card that we are going to be using to boot up the system. It takes a few minutes to write and verify the image, and once that's complete, we can proceed to remove it and insert it in the Jetson. When we flash the Jetson with the micro SD card inserted, we will be stepping through the normal process of installing Ubuntu. And these screens should be familiar to you if you have installed Ubuntu before. It's a simple wizard that will get some basic information from you and then set it up with the default options. You can, of course, later on go ahead and tweak your variations of the operating system that you want, but be warned that this is a highly customized version of Ubuntu and that you should not do any experiments on the operating system without the blessing of NVIDIA. Jetpack 6.2 provides Jetson Linux 36.4.3 with Ubuntu 22.04 long-term support LTS and extensive NVIDIA updates. The Maxine Super is an uncapped power mode that allows the highest number of cores and clock frequency for CPU, GPU, Deep Learning Accelerator DLA, Programmable Vision Accelerator PVA, and System on a Chip SoC engines. TensorRT, DLA, and Compute Unified Device Architecture CUDA are for deep learning operations. CUDA Toolkit enables building GPU-accelerated applications. Multimedia API offers flexible application development, especially for cameras and video processing. Computer Vision offers April Tag Detector and Pose Estimator. Graphics support for the popular libraries like Vulkan and OpenGL has been updated. In short, Jetpack 6.2 will help you to make more productive use of the Jetson Orin Nano. We simply need NVIDIA to solve the Docker issue sooner rather than later. After you've downloaded the Jetpack 6.2 package from the NVIDIA site, you can go ahead and run it to perform the upgrade. The upgrade follows the standard Ubuntu upgrade process, and my apologies for not capturing the screen properly. And so what I've done is showing you fixed slides of certain images that I thought were pertinent to give you an idea of the progress of the update. So once the update is complete, then you will have to perform the power mode change to Maxine Super. And as we'll step through in a minute, once the upgrade is complete, the Ubuntu background screen will be displayed, and the toolbar at the top will have a power button which you can select to choose one of the three options for the power mode. Naturally, the whole purpose of getting the Jetson Orin Nano SDK is to be able to use its full potential, and that comes through the choice of max and super setting. So here we go. After we finished the upgrade, on the top right hand corner in the toolbar, you will see the power button. Select that, and from the drop down menu you can select max and super. If the quad serial peripheral interface QSPI updater was run successfully during the firmware upgrade, network connectivity may have been established already. But in any case, check that your preferred network connectivity is active and that the secondary connection can be configured should you wish to. Running AI models on an 8 GB computer may require more swap space. Change the swap space to 8 GB. Use the SSD for this purpose too, if available. To run the Orin Nano in headless mode, it is desirable to leverage passwordless SSH connectivity. VNC or REMMINA are options too, but the graphical user interface with these two interfaces may pose additional demands on memory for remote access. The Orin Nano requires the use of a dummy monitor for remote desktop connection with a graphical user interface. This dummy monitor must be disabled when connecting locally for GUI operations. This is a limitation that requires one to save 2 configuration files for display purposes and to activate one or the other as appropriate. Other single-board computers do not suffer from this handicap, so it is not clear what NVIDIA engineers were thinking when confronted with this workaround. Finally, disable services that are unnecessary for your work and were probably installed by default. Once the Orin Nano is running under Jetpack 6.1 or later, you should unlock super performance by setting power mode to max and super. Click on the NVIDIA button on the main menu bar towards the upper right corner of the display screen. Select Power Mode from the drop-down menu. Select Max and Super from the Cascade menu. The main menu bar should now display your last selection. The Orin Nano is now ready to perform in super performance mode. NVIDIA provides the NVP model tool to set different power and performance nodes on Jetson devices. To verify that the performance mode is working correctly, monitor the performance using TegraStats, which provides real-time data on CPU, GPU, and memory usage. Higher performance modes dissipate more heat. Ensure adequate cooling for your device when operating in these modes. Before we start working on tutorials, let us review the storage options briefly. We could use either a micro SD card or a solid storage drive (SSD) exclusively. The micro SD card would retain the OS and support files while the SSD would contain the AI containers. Alternatively, we could simply use the SSD for both the OS and the containers. The Orin Nano has two M.2 connectors to host two SSDs. The two slots are for two different sizes of SSD. Let us review the installation of an SSD on the Jetson Orin Nano. The first step is to unplug the power to the Orin Nano. Then install the SSD, ensuring that it is seated properly. Power on the Orin Nano. Locate the SSD using the lspci command. If it is detected, then run the lsblk command to find the device name. Format the device. Create a mount point. Mount the SSD. Determine the UUID of the SSD. Update the /etc/fs tab with the UUID of the SSD so that it will auto-mount when it's rebooted. And then finally, change the ownership of the SSD. Let us proceed with the installation of the SSD on the bottom of the Orin Nano. There are two M.2 connectors supporting two different lengths of SSD modules. The shorter one is 2242, that is 22 millimeters wide and 42 millimeters long. We will use the 2280 M.2 connector, which is 22 millimeters wide and 80 millimeters long. This slot has better heat dissipation owing to the larger surface area. We will limit ourselves into using a 1 terabyte SSD, even though larger capacity SSDs are readily available. After the SSD has been securely fastened, place the Orin Nano inside the case and plug the initial set of cables, the Ethernet, keyboard and mouse combo, webcam, DisplayPort, and finally connect the power cable. Let us now connect to the Orin Nano in headless mode. We will use passwordless SSH from another computer. Let us log on to the Jetson and check the status of the Docker service. So I'll use passwordless SSH for this purpose. And once we're in, we just do a simple systemctl status docker. And as you can see, there is an error and Docker service is not running. This is because Jetpack 6.2 is not compatible with the current Docker service. So let's go ahead and look at the Docker version. And if we see, it's 28.0.0. And we really need to have Docker 27 running under this version of Jetpack. So we have to downgrade our Docker. And let me show you how to do this. This issue arose because when installing Jetpack 6.2, there is no Docker service available in that package. And that is a deliberate omission by the NVIDIA development team. And when I tried to install Docker separately, naturally it got the latest version and I ignored the error messages, and now I have to pay the price by going ahead and downloading an older version. There is another way to do this, which is to use a kernel upgrade, but for simplicity, I'll just settle for the first option, which is to downgrade my Docker instance. So the first command, there are three basic commands to run to do this. The first one is to install a specific version of the Docker core engine. And I'll go ahead and complete that. And once that's done, now I need to install the command line add-on for Docker. As you can understand, Docker has two different packages. One is the backend core and the front-end Docker command line through which we type in all the Docker commands. And now that we've downloaded the two key parts, let's go ahead and install them and set the environment variable. So this time it would be a good idea for us to check the Docker version that we've installed just to satisfy ourselves. So let's go ahead and check the version of Docker that we have just installed. And as you can see, it's 27.5.1, which is what will run under Jetpack 6.2. So let's go ahead and ensure that the service is up and running. And we can use the systemctl command. And now you see there are no error messages, and it's clearly active. One more check that we have to perform is to ensure that the current user is a member of the Docker group. So let's do that now. And sure enough, the user is a member. And so we can proceed to running a simple Docker instance to validate that the service is working properly. Now that the SSD is installed and available on the Jetson, we can use the extra storage capacity to hold the storage demanding Docker directory. So the first step is to stop Docker from running currently. And once that's done, we will move the existing folder that we have to our new Docker directory on the SSD. So the first command is to figure out the storage utilization of the library files for Docker. And it's going to give us a summary information. So as you can see, we are already using 15 gigabytes on the micro SD card that I used to boot the Jetson. And this is another case where perhaps the second M.2 connector could be used for another SSD where the OS will run. But anyway, let's go ahead and now create a directory for the Docker files. So it'll be in the slash folder, which is our SSD, and we create a folder called Docker. And now we'll transfer all the files using our familiar rsync procedure. So and we let it run. So here's the rsync command with a few options, and it's a simple, straightforward transfer of the library files. So it's 15 gigabytes. It'll take a while. So let me stop the video and get back to you when all the files have been moved. Now that the transfer is complete, let us go ahead and check the storage for the new folder. And it's just gone up by a little bit because of some housekeeping files. And it's in the same ballpark. The next thing to do for us is to ensure that the name of the old folder is changed. And that's an important step so that you don't accidentally start using that. So we'll go ahead and rename it. And that's done. And now we have to go ahead and edit the JSON file for Docker to let it know that it has to use a specific instance as the default. And we have set it up as NVIDIA, but we haven't told it to go and pick the non-standard folder. So we have to specify data root need to get my JSON fixed. So this is the change that we did. We added default runtime previously when we were exploring the original Docker instance that didn't run, and now we've told it to go and pick the root. So if I spell correctly, it should be okay. Let's go ahead and save it. And now we'll restart the Docker instance. So sudo systemctl restart Docker. And we can check if there are any error messages in the journal file, right? Oops, sorry, journal. If I again know how to spell correctly, life would be simple. And it's up and running. So let's go ahead and check the current Docker version. And we run this. There are two parts to it. First of all, the Docker engine, and that's at 27.5.1. And then we have the detailed information in here. And remember, we're using the community edition here. Let's go ahead and test Docker on the SSD. And the best way to test it is to see if the storage space on the SSD is increasing as we pull in new Docker containers. So we need to set up a size watcher on another terminal, and we'll watch all the folders, all the file systems in there. So we have SSD at 2%. And now moving over to the original console window, we can pull in a Docker instance. And as it's pulling it in, the file space on the SSD will start increasing. So let's go ahead and check that. So let's do a good old-fashioned Docker image check. So we'll do a Docker image list. And you can see it's downloaded 22.04 Ubuntu with 69 in there. And that will allow us to see a nominal increase, if at all possible. Since we're using a very large disk space, we didn't quite get the increment that we were looking for. For the final confirmation in this session, we will just run the docker info command and extract runtime data. So you can see that it's using the NVIDIA container as the default, and the SSD Docker folder for the data. These are the changes that we made in the JSON file, and they're reflected in the Docker info output. So we've downgraded Docker to 27.5.1. We've also moved the data storage folder over to the SSD, and we pulled in a Docker container and showed that indeed the SSD is being used. Let's go ahead and do a very simple TensorFlow exercise with this command in here. So it's going to go ahead and pull in the components, and this will take a while, but hopefully you get the idea that it is better to run Docker on the SSD because of the enormous amount of storage requirements that it imposes on the system. If you want to learn more about Docker, it's best to use the Docker container called Getting Started to practice through the exercises. So the command to download that is shown up here: Docker run, and then the options, download the image if it's not available, and then redirect port 80 to port 80. So the container is called Docker Getting Started. And let's go ahead and execute this command. So it's downloaded, and now let's take a look at what we have here in terms of images. And you can see that there is an image that we've just downloaded, and the name is Keen Lamar. So the way to access this from my SSH session would be to launch a browser and then go ahead and point to the instance. So switching over to the browser, I type in the address of the Jetson in the address bar, and as soon as I select that, you can see that the tutorial is running on the Jetson. And this is a nice little documentation by the Docker team explaining what's going on. So you can see here what we just ran, and then it explains the Docker dashboard. And there are some more instructions in here and helping you understand how to navigate here through Docker. Since this is not a Docker tutorial, I'll leave it to you to try it out on your own. The current Docker version 28.0.0, requires a kernel configuration that is not available in Jetpack 6.2, which installs NVIDIA core version release 36.4.3. Therefore, we have two choices: either downgrade to Docker version 27 or build a new kernel. If you don't need the latest and greatest from Docker, downgrading Docker to version 27 is a better option than rebuilding a new kernel. This preferred option will not upset the apple cart of lower-level hardware and software dependencies. In the interim, the best brains at NVIDIA are working on resolving this issue, but there has been no announcement on general availability of any software fix. The two core components needed to run Docker on the Jetson Orin Nano are Docker CE and Docker CE CLI. Docker CE is the main Docker engine. It contains the Docker daemon, Dockered, and the necessary runtime components. This package is the core of Docker. Docker CE CLI package provides the Docker command line interface, Docker, which allows you to interact with the Docker daemon. This package contains the Docker command. Without this command, you cannot send commands to the Docker daemon. Why are these two essentials? You might ask. The Docker daemon, Dockered, is the background service that manages Docker containers and images. The Docker CLI, Docker, is the tool that you use to give instructions to the Docker daemon. Therefore, to have a fully functional Docker installation, you need both the engine and the command line interface. So let us see these commands in action now. Once you are up and running with the Jetson Orin Nano in Super Maxin mode, in other words, you are running Jetpack 6.2 or later, you will want to explore the Orin Nano in a deliberate, stepwise manner. The first stop should be the Jetson Orin Nano Developer Kit User Guide. This document contains more detailed information on the hardware and some advanced topics such as how to create your own custom jetpack. The NVIDIA Jetson Developer site is a source of information on the platform. There is the NVIDIA Deep Learning Institute for self-paced and instructor-led training. We will cover some of the tutorials shortly. Don't forget to register at the NVIDIA Jetson Forum to stay in touch with Jetson Orin Nano developments. NVIDIA provides the Jetson AI Lab to provide tools and resources for developers on generative AI at the edge. It serves as an educational platform enabling developers and enthusiasts to gain hands-on experience with vanguard technologies with practical applications of AI in various fields such as robotics, computer vision, and Internet of Things. And don't forget to register at the NVIDIA Jetson Forum for knowledge sharing, support, and troubleshooting. By participating in community efforts, you will benefit from staying current and receiving specific support for your hardware devices. Ollama is an open source tool that simplifies the process of running large language models, LLMs, locally on a desktop. Some of the notable features are local LLM operation. Instead of relying solely on cloud-based services, Ollama allows you to run LLMs directly on your own hardware. This offers benefits like increased privacy, reduced latency, and potential cost savings. Simplified LLM management. Ollama streamlines the complexities of managing LLMs by packaging model weights, configurations, and data into a single, easy-to-handle package. Privacy and control. Because the models run locally, your data stays on your machine, which is crucial for sensitive information. Flexibility and customization. Ollama provides the flexibility to customize and fine-tune LLMs to suit specific needs. Open source. Ollama is open source. This allows for the community contributions and transparency. In short, Ollama makes it more accessible for anyone interested in leveraging the power of LLMs to do so in a local and controlled environment. Ollama has support for the Jetson platform with CUDA support. enabling Jetson users to seamlessly install Olama with a single command and start using it immediately. There are two subsystems to the installation of Olama: the server and the client. There are two ways to install the Olama server. The first one is to rely on native installation using the official installation script. The second one is to use a Docker container that isolates the changes to the Blaze platform. The client can be run inside the Docker container should that be the preferred installation method. The Jetson Orin Nano must be running Jetpack 6 or later with abundant storage. In other words, an SSD is highly recommended. The most common and recommended method to install Olama is to rely on the official installation script. Open a terminal window and enter the command shown on the slide. This command downloads the installation script and immediately executes it. During the execution, the necessary setup steps are completed. The install script will download the Olama binary and place it in a location that is within your system's path environment variable. It is generally recommended to have your system updated before installing any new software. Therefore, running the apt update and the apt upgrade commands with elevated privileges before installing Olama is a good practice. And finally, when you've completed the installation, just type Olama at the command line to see whether it is accessible. There are two usage modes when Olama is invoked from the command line using the command Olama. The first mode uses flags as parameters to provide information on the application. There are two basic parameters: help and version information. The version parameter will list version numbers for the client and the server. The commands require additional parameters. For example, run will require a specific run model name. If it is not available locally, it will download it as appropriate. The serve command to start Olama is strictly not necessary if the Olama server is started during boot by the system. You can obtain more information about a command by appending --help to the command line. Olama offers ease of model download and management, interactive model session, basic command line functionality, speed and local processing, model customization. Let us examine each of these topics serially. Olama offers a simplified download process that handles model selection from a range of model size spectrum: small, medium, large, and very large. Locating model weights from the Olama library. Downloading the necessary files. Verifying the integrity of the downloaded files. Storing the model in the correct location. Provide progress indicators during downloads to track the process, since some models are very large. Manages error handling and network issues during download. You still need to ensure that the network connection is stable and there is sufficient disk space. Ollama facilitates interactive model sessions by providing a simple and direct way to engage with the large language models, LLMs, through its command line interface. The core of Ollama's interactive capability lies in the Ollama run command. When you execute this command without providing a specific prompt as part of the command itself, Ollama initiates an interactive session. This design choice is key. It immediately places the user into a conversational mode with the chosen LLM. Once the interactive session starts, Ollama waits for user input. You type a prompt or question and then press the Enter key. Ollama then processes your input using the loaded LLM and displays the model's response directly in the terminal. After displaying the response, Ollama prompts you for further input, allowing for continuous back and forth conversation. While Ollama itself doesn't maintain long-term persistent memory between different run sessions, within a single Ollama run session, the model itself will maintain context according to the model's capabilities. This allows for follow-up questions and related queries, making the interaction feel like a natural conversation. It is important to understand that when the Ollama run command is exited, that conversation context is lost. Ollama uses the terminal as its interface, which is straightforward and widely accessible method. This simplicity removes the need for complex graphical user interfaces, making it easy to use Ollama on various operating systems. Because Ollama runs LLMs locally, it can provide relatively fast response times, especially on machines with powerful hardware. This responsiveness is crucial for creating a smooth and engaging interactive experience. Ollama's design philosophy prioritizes simplicity and directness. By using the Ollama run command to create interactive sessions, and by using the command line interface, Ollama enables users to have a natural and efficient conversational experience with LLMs. Ollama demonstrates speed and local processing in a session through a few key factors that become apparent during interaction. Reduced latency. Because the LLM runs directly on your machine, the time it takes for your prompt to travel to a remote server and back is eliminated. This significantly reduces latency. You'll notice that responses appear more quickly compared to cloud-based LLM services, especially for shorter queries. Offline functionality. Once a model is downloaded, Ollama can operate entirely offline. This demonstrates the local aspect of processing. This is a major advantage for privacy and reliability, as you are not dependent on an internet connection. Offline operation also ensures consistent performance, as it's not affected by network congestion or server load. Responsiveness in interactive sessions. During an interactive session, the speed of responses creates a more natural and engaging conversational experience. Resource utilization. Use the Linux commands top or htop to view local processing power being used. When using Ollama from the command line, maximizing productivity involves a combination of general command line best practices and Ollama specific techniques. Command history. Use the up and down arrow keys to navigate your command history. This allows you to quickly recall and use previous commands, especially when experimenting with different prompts. Control R for reverse search is incredibly useful for finding specific commands you've used before. Tab completion. Utilize tab completion to quickly fill in command names and model names. This reduces typing errors and saves time. Aliases. Create aliases for frequently used Ollama commands. This method shortens your commands and streamlines your workflow. Screen. Use screen to create persistent terminal sessions. This is very useful for long-running operations. Redirecting output. Use redirection to save Ollama's output to a file. Piping. Use piping to send output to one command or to another. Ollama specific productivity. Direct prompts. When you know exactly what you want, use direct prompts in the run command. This avoids the need for an interactive session and saves time. Model management. Use list and RM to manage housekeeping for your models. Experiment with prompts. Maintain separate text files of useful prompts. You can quickly copy and paste these into the command line. Stay current. Ollama has frequent updates. Check often and use new features as appropriate to be productive. Use scripts. For repetitive tasks, create shell scripts that combine Ollama commands with other command line utilities to improve your productivity. From a market capitalization perspective, NVIDIA is one of the top 3 companies in the world. And so naturally, it has a very diverse range of products. And the Jetson, as you can see in the last column, top row, is a small segment of what it does. But nevertheless, it's an important segment as far as hobbyists, enthusiasts, and early adopters are concerned. So when we select Jetson from the drop-down menu, we land on this page, and let's click on hardware here, and we come to the information about the Jetson hardware. And what we're trying to do is use the Jetson Orin Nano SDK for our tutorial in here. So this is the page that you can go to if you want to learn more about the Jetson Nano Orin SDK. As you can see, it's very easy to get lost in the choices here. So the best thing to do is to click on For You on the toolbar and then drill down to Developers. And under Developers, there is a section called Developer Home for developer resources, where you should be able to navigate quickly to find more information about the development platform that you're working on, which is the Jetson Orin Nano SDK. So you can go ahead and then click that information in here and search for Jetson. And it comes up with the information about the Jetpack for the SDK. Currently, the latest version is 6.2, and that is what you should be using to get the max and super performance from the Jetson. Having navigated our way to the Getting Started page, we can now scroll down and come to this section on Jetson Orin Nano Super Developer Kit. There is a very useful starting guide that should help you understand a little bit more in details than what I can do in this presentation. So obviously the interfaces are defined, and then what else do you need to have in order to run the Jetson as soon as you unbox it. The key steps are listed in this section here. Foremost, update the firmware. Very important. Then you can write the image to the micro SD card or to an SSD if you want to. Set up and first boot, and then you go through 2 more reboots, and then you unlock super performance and then move on to the tutorials. The Getting Started guide for the Orin Nano SDK has some very useful information on how to navigate through all these pages at the NVIDIA website. But more importantly, what I want to do is introduce you to this thing called Jetson AI Lab, which has some very nice examples, and you can follow these tutorials on your own. And obviously, each tutorial would probably take as much time as this single tutorial that I'm presenting. So if we click on Jetson AI Lab, we can see that there are a whole series of tutorials on different categories. And while I'll try to demonstrate a few here just to help you get started, I will start with the simplest of all examples, which is object detection. The Jetson AI Lab has a very nice section called Hello AI World. And as you can see from the images on the screen, the classic object detection, classification, segmentation are provided as simple tutorials for you to get your hands on. There are a couple of other extensions like pose estimation, action recognition, background removal, and much, much more. So obviously, it makes sense for you to go ahead and try this out. And the way to do that would be to just clone the GitHub repository and run the examples from there. So if you want, in a future tutorial, we can do this, but it'll take a few extra cycles at this end here to do this in this tutorial. If you are very excited about recent developments in generative AI, especially with the Sputnik moment regarding DeepSeek, I would recommend that you take a look at Ollama with OpenWeb UI. So if we click on this link here, it'll take us to this tutorial on Ollama, which is initially for you a text-based approach, and that's the best way to get started. This will allow you to ensure that Ollama is running on your Jetson in a text mode, and then you can migrate to the OpenWeb UI. So OpenWeb UI requires Docker, and as we have shown previously, we did get the right version of Docker installed, and Docker is up and running on the Jetson now once you followed the steps. But nevertheless, still, just try to run Ollama on its own and get that going. It's text-based, and so you may have some challenges, but once that's done, you can easily migrate to using Open Web UI. Open Web UI is a user-friendly, browser-based interface to interact with large language models, LLMs. It is designed to run with LLM runners like Ollama. There are 3 ways to deploy Open Web UI. First, leverage the back-end Ollama server and install just the Docker container for Open Web UI. Second, run the Open Web UI Docker container and then run the Ollama Docker container. The third is use a script to launch both containers. We will demonstrate the first method to deploy Open Web UI. Retrieval augmented generation enhances capabilities of LLMs by allowing them to access and incorporate external sources into their responses. RAG improves accuracy with up-to-date information and the ability to append specialized knowledge bases, for example, legal, medical. RAG bridges the gap between static knowledge of LLMs and the dynamic, ever-changing world of information. It enables LLMs to provide more accurate, relevant, and trustworthy responses. Access Open Web UI through a browser by appending the port number 8080 to the address of the hosting server, which is the Jetson in our case. Complete the account creating process. The credentials are stored locally. They are not verified or stored externally. Download a small language model, SLM. You can disconnect the Jetson from your external connectivity after the download to reassure yourself, but then you must launch the browser locally on Jetson. Start interacting with the download model. Create a knowledge base for RAG. Add files to the knowledge base. Create a custom model with knowledge base access. Configure the model. Interact with your custom model. Since we have already installed Ollama on the Jetson, let's just go ahead and install the Open Web UI Docker container. So the command from the knowledge base is given in here, and hope you get some time to read the information. Let's go ahead and just run it anyway. So it's unable to find the image locally, which we understood is quite appropriate since this is the first time we're running it. So it's going ahead and downloading the Docker container from the Open Web UI's website. And now that the installation is complete, we will launch a browser to the Jetson and assign port 8080. So now that we've downloaded and started the Docker container for Open Web UI, let's go ahead and access it. So it's running on 172.16.0.32 on port 8080. And if I hit that, you can see the authorization screen comes up, and we'll go ahead and select Get Started. So it's asking us for a name in here. and I'll just say it doesn't validate anything, so we can use whatever we want, and a password is fine. And I will use a securely generated password for this site, so it keeps an admin account for us, and we can go ahead and tell it to update it. And now it gives us information about any late breaking news, and we can select a model, and obviously we can go and search for a model. And the best one that I would like to use is, let's just say we look for Jam, and we say we can pull Gemma from there, and it's going ahead and downloading it from Olama. And it'll take a while to do that because it's a large file, but once that's done, we can go into the UI and start working with it. And as you can see, it's going to take a while. We're only at the 4% mark right now. So I'm just going to pause the video and let the download complete before I resume. Now that the download is complete, it's verifying the checksum. And once that's complete, we'll go ahead and run a very simple query to see what Gemma can do for us. But want to emphasize the fact that this is not the tutorial for Open Web UI, just to let you know that it is very easy to get started with Open Web UI on the Jetson, as long as you have the right version of the Docker container, which is version 37. There should not be any hiccups given the excellent documentation provided by the NVIDIA developer AI site. So now it's going to ask us if we want to pull Gemma. Yes, we certainly want to pull Gemma. It's been downloaded, and we can go ahead and ask a question. So the first question that we want to ask, and we can do it through video, audio, or however we want to do it. So there are many ways of capturing the files, uploading it, or we can go and say, for a random fact about the Roman Empire, and let it go and retrieve that information for us. So we select the model that we want to use, which will be the Gemma latest, and we can. It is very important to use the correct version of TensorFlow on the Jetson Orin Nano. Keras is included in TensorFlow generally. NVIDIA provides the TensorRT for deep learning inference. It accelerates the execution of trained models on Jetson devices. You can develop directly on the Jetson Orin Nano. You can train your models on a more powerful machine and then deploy these on the Jetson Orin Nano for inference. Use the official NVIDIA documentation for guidance on installing TensorFlow. The standard method of using pip install will not provide the correct environment on your Jetson Orin Nano for this purpose. TensorRT is essential for optimizing and accelerating deep learning inference. There are Docker containers for the large number of models where quantization, pruning, and distillation provide efficient inference on the Jetson Orin Nano. Choose generative AI models that are suited for edge deployment and convert these to TensorRT format if they are not already available. Of course, deploying Olama is an efficient approach to using generative AI for edge development. Vision processing is what OpenCV excels at. Jetpack includes an optimized OpenCV version. Of course, OpenCV can be built from source with CUDA support on Jetson Orin Nano. Memory management between CPU and GPU requires the use of the OpenCV module called CUDA GPU mat to store images and data on the GPU. Typical OpenCV applications are data processing, detection, and classification. Using the OpenCV package for Jetson products, one can optimize the performance by minimizing memory transfers between CPU and GPU, using efficient algorithms, and leveraging multi-threading. Some typical applications are real-time object detection and tracking, image classification and recognition, video analytics, robotics vision, industrial vision, edge AI vision. YOLO offers another dimension for generative AI at the edge with real-time performance, accuracy, and efficiency, edge deployment, flexibility, and customization. YOLO offers the speed, accuracy, and efficiency to make it a perfect fit for the capabilities of the Jetson Orin Nano. Now that YOLO 12 is available, you can expect some tutorials on using this version of the Jetson Orin Nano. The NVIDIA Jetson Orin Nano SDK supports Robot Operating System (ROS) for robotics development in computer vision, sensor processing, and navigation. Robots can perform object detection, path planning, and real-time decision-making more effectively. NVIDIA Isaac ROS leverages the Jetson platform's GPU capabilities to build and deploy advanced ROS-based robotic system. We will demonstrate some Hello JetBot exercises in a future tutorial to demonstrate these capabilities for object detection, image classification, autonomous navigation, and line following. This short tutorial highlighted the key features of the NVIDIA Jetson Orin Nano Super Developer Kit or SDK. Since no release date for the Jetson Thor that uses the Blackwell architecture has been broadcast, you could use the Jetson Orin Nano to sustain your knowledge in generative AI at your own pace by emulating the dozens of tutorials published by the various NVIDIA teams. And of course, there is the NVIDIA Deep Learning Institute that offers many courses at all levels for those who wish to ramp up the learning curve at a much faster pace. That's all, folks. Thanks for taking the time to view this presentation. Would love to hear from you with your feedback. You are always welcome to be critical in any which way you can. Until next time, bye for now. This presentation was prepared with assistance using free open source software, FOSS, from Olama, Open Web UI, OpenCV, Ultralytics, TensorFlow and Keras, OBS Studio, Kdenlive, LibreOffice, and of course Ubuntu. Teachers, viewers, and peers provided valuable feedback. My apologies if I have inadvertently omitted anyone from this acknowledgement. A very big thank you to y'all for the assistance.